In today's video, we will be looking at the finite element analysis of a simply supported beam subjected to point load at the center. The topics are as follows. First is the problem definition. Then we will use the analytical method to solve the problem. Then we will solve the problem by the FEA method. And after that, we will simulate the problem in the Ansys Workbench and compare the results. The problem is as follows. A simply supported beam is subject to a point load of 1,000 newtons. The beam has a square cross section with sides of 20 millimeter. The length of the beam is 1 meter, and the material has a Young's modulus of 240 gigapascals. Find the maximum deflection, slope, and force reaction. Analytical method to solve the problem is as follows. We derive using the double integration method, and using the boundary conditions, we find the function of slope deflection. From the function, we can find the maximum values of slope and deflection, which are shown on the slide. Using the equilibrium condition, we find the reaction forces. The governing equation for beams is shown, and using the finite element method and boundary conditions, a general elemental matrix can be obtained. For this problem, we will consider two elements. So we write the elemental matrix for each element. After the elemental matrix, we will assemble the global matrix and combine elements 1 and 2 by applying the boundary conditions, which are as follows. The node 1 and 3 are fixed, which means the vertical deflections B1 and B3 are 0. As we know, the maximum deflection occurs at L by 2. Therefore, the slope is 0 at node 2. The unknown is deflection at node 2 and slope at nodes 1 and 2. We obtain the equation, which is solved to find the unknown. From the obtained unknown, the force and moment are also calculated. Now we move to the Ansys Workbench for the simulation. So for the simulation, drag and drop static structural into the Workbench project. Comes from the edit the material properties as per the given data. Now open design modeler, change the units. For this case, we choose the YZ plane, draw the rectangle, and give the dimensions as follows. Extrude the sketch using the extrude command located in the create option. Select the sketch, change the operation to add frozen, and give the depth as the length of the beam. Click on generate. To slice the body, create a new plane with an offset. I'm going to go to the create option and choose the slice command, select the sketch and bodies to be sliced. Click on generate. Form a new part and check the share topology option. Slice is used because we need an edge at the center of the beam for applying the force. One can also use the face split method to generate the edge. Now we will go to Ansys Mechanical for the analysis, check the material assignment in the geometry option, generate mesh, insert the force and select the edge. Choose component and enter the value. For the fixed support, instead of directly applying the fixed support, we will apply displacement at both ends. For that, we will first create the cylindrical coordinate system on both faces. Note that the origin of the coordinate system must pass through the neutral axis of the beam. insert the displacement, and select the face. Choose the created coordinate system instead of global and constrain X and Z motion. Similarly, apply displacement at another end, select face, choose the created coordinate system instead of global, and constrain X and Z motion. Note that applying the fixed support and displacement is the wrong approach, since the simple supported beam means the vertical movement is 0, but the slope is not 0. Therefore, the fixed support violates the condition. This is the accurate approach that comes from the theory. Insert total deformation and choose all bodies. For force reaction, go to Insert, choose Probe, select Force Reaction, and in that, choose Displacement. Similarly, insert the force reaction at the other end, go to Insert, choose Probe, select Force Reaction, and in that, choose Displacement. Note the value. To plot the displacement versus length graph, we will first need to create the path. Select Model and insert the path under the construction geometry. Give dimension as the line passes through the neutral axis of the beam. Now insert the directional deformation. Instead of geometry selection, change to path and choose the path we created. Change the orientation to y-axis and evaluate the result. From this graph, we will calculate the slope using curve fitting. Save the project. The result is tabulated. The deflection, slope, and force reactions of Ansys match the analytical and FEA Matrix methods. Note that for result purposes, we took the absolute value. The references are as follows. That's all for today's video. Thank you.